my trinomial solutions for 7 and 8. Verify with yours, please. Seven, it said I got 10x squared plus 13x plus 4. And 8, I had 10x squared minus 3x minus 4.
Oops. Sorry about that.
And then should I be? When I look over here and see a 2 and a 5? Nah. Should I be surprised that my last term is a 4 when I look over here and I see a 1 and a 4? No. What is surprising is the middle one. Because there doesn't seem to be a nice way to get to the number 13 using 2, 1, 5, and 4. It's not clear where that 13 came from. In example 8, 2 and 5, no surprise about the 10. 1 and negative 4, no surprise about a negative 4. Little surprising, negative 3. Again, 2, 1, 5, minus 4. It's not clear why that turns into a negative 3. We'll have to come back to that. Page 3. Here we go with factoring. This is now phase 2 factoring. What happens when phase 1 fails? Phase 1 was looking for a greatest common factor. X squared, 6x5. Do they have a greatest common factor? They do. It's 1. But what good does factoring out of 1 do? Because what would be the pairing for my factor of 1? Exactly this thing again. It does me no good. So phase 1 factoring failed. Phase 2 factoring will succeed in this particular case. Do you know two numbers that add to 6 but multiply to 5? Add to 6, multiply to 5.
1 and 5.
1 and 5. My factors are going to be x plus 1, x plus 5. I'm just reversing what we did on the previous page. Do you know two numbers add to 6, multiply to 8?
2 and 4.
4 and 2. X plus 4, x plus 2. I do my distribution, I do my foiling back out. I will result with this desired trinomial. 10 and 16, add to 10, multiply to 16. 8 and 2. X plus 8, x plus 2. What about the next one? 6 and negative 16. Ooh, I heard it. Who said it? 8 and negative 2. 8 times negative 2 is 16. How much is 8 minus 2?
6.
6. X plus 8. X minus 2. You can just throw it right at it. Add to negative 6. Multiply to negative 16. Negative 8 and positive 2. How about the last one? What's the middle term that's missing? The 0, right? So we're looking for things that add to 0, but multiply negative 64.
8 and 8.
8 and negative 8. Was that difficult? Not if you have that pattern that you're looking for, right? That's phase 2 factoring. We call this quadratic trinomial factoring. If you come across a situation where you cannot find a greatest common factor, this is your secondary option. Greatest common factor is primary option because it's the easiest. This is your secondary option if that one failed. These, however, phase 3 factoring. We now have a coefficient here of 2. We have a coefficient, a term here at the end of 15. This is like number 7 and 8 that we just saw where we follow a different rule. What are some numbers that would multiply to give me 2? 2 and 1. How about 15? I heard 5 and 3. What else? 1 and 15. I know there is some combination where I have 2x in my first parentheses, x in my second set of parentheses, and some combination of this 5 and 3, or this 1 and this 15, which would give me that desired value of 11 down the middle. There are 1, 2, 3, 4. 4 possible combinations that we would have to try. One of them will be successful. 3 will fail. I want somebody to select one. Let's see if it passes or fails. Jared, which would you like me to try first? 2 and 3. 2 and... I can't go 2. How about 5 and 3? Sure. 2x times x, 2x squared. Good so far. 2x times 3, 6x. 5 times x, 5x. How much is 6x and 5x?
11x.
Did it do what I wanted to do?
Yes.
Good choice, Jared. Lucky guess. We had 4 choices. He picked the magic one first. Probably not going to happen on the second one. This one has a lead coefficient of 6. What are the possible factors of 6? 2 and 3. 6 and 1. Possible factors of 15. 1 and 15. 3 and 5. I now have 4 possible choices for the beginning of my sets of parentheses. 4 possible choices for the end of my parentheses. 4 times 4 is 16. We have 16 possibilities to try to find the combination that will give me the 33 down the middle. 15 will fail. 1 will pass. How much time do we have left? 10 minutes?
10. 5.
I'm not going to make you try this one on your own. I'm going to give you the answer, but when you go home, I would like you to try figuring out how these 2 numbers work and why the other ones don't. All right? I don't want to be pressed for time at the end of this, but it's trial and error, except there is a little bit of a faster way. I'm not going to teach it to you because it's too complex, but if you look on the very bottom of the last page, you will see there's a YouTube URL. There's a crazy old lady on YouTube who can teach you how to do this a more efficient way than guess and check. So if you have the time, take a look at it. It's like 16 minutes long. She does a reasonable job with the explanation that I just don't have the time to do. So in this case, let's see. This one would go, this is the combination that works. 6x plus 3 and 1x plus 5. That's the combination that would give me the 33 down the middle. 6x times the 5 would give me the 30. 3 times x would give me 3x. 30x and 3x gives me my sum of 33x. The others will all fail somewhere along the way.
Mr. Meyer, should they factor out the common factor in the 6x plus 3?
Next page. Roots. What are roots? Well, another name for roots is zeros or solutions. Now, the very first day I taught one of our X block sessions, the first thing we started off with was, what is a solution? It's a number or set of numbers to replace a variable or set of variables to make a statement true. All right? If we're looking for zeros or roots, we're looking for statements that will make a statement equivalent to 0. So it is a value or values that satisfy an equation equal to 0. Right, so we're looking for numbers that'll make an equation equal the value of 0. Zero product property. This is something that goes back to probably second grade. What is the only way I can take two values, multiply them together, and get a product of 0? If A times B equals 0, you know either A equals 0, B equals 0, or both do. It's the only way you can get a product of 0. Either the first one's equal to 0, the second one's equal to 0, or, by some chance, they're both equal to 0. No other way to get a product equal to 0. Flashback. We just saw this problem a minute ago. Except I took our expression and I made an equation. We looked a few moments ago. We had x squared plus 6x plus 5. We wanted to factor it. Well, now I'm setting it equal to 0. And I am showing you it in its factored form. This is the exact problem we did, what, 2 pages ago? 1 page ago? Last page. This was the beginning of phase 2 factoring. These two things together multiply to give me a product of 0. One of those things must be 0 itself. What number or what value must x take for this to equal 0? What must it equal? -1. Or perhaps, here's my 0. What would be the other possible value? Sabrina? -5. How many solutions are there? 2. How many roots are there? 2. There's 2 possible numbers that would make this equation equal to 0. For number 2, what are the possible roots or zeros here? Victoria? And again, we did all this grunt work earlier, we did the factoring earlier, now we're putting it to work for us. Why would we want to factor? Because it'll help me find my zeros, it'll help me find my roots. We start with x squared plus 10x plus 16 equals 0. Factored form, x plus 8, x plus 2 equals 0. What are my possible roots? Yes?
-8 or -2.
-8 or -2. Number 4, roots, yes?
Me?
Yes, you.
8, -8, positive.
-8 or positive 2. Number 5. Okay.
-2 or 8.
-2 or 8. Number 6. So, 8 or -8. Number 7. This is where we get a little twist. Not quite so easy. Sophie?
-5 or -3.
Not -5. I like the -3. But if I want this to equal to 0, 2 times 5 would be 10, plus 5 would give me 15. 2 times what number would give me my value of -5? So I'd have 5 plus -5. What number is that? -2.5. If I put in -2.5, 2 times that gives me -5, plus the 5 gives me my big 0. Little tougher if I have that extra coefficient in there. And the last one. Let's see, we got 6x plus 3 and x plus 5. There's an easy one, there's a harder one. What do we got here?
-half and or -5.
Or -5. Nice. The -half, because -half times 6 is -3. You add 3 to it. 3 and -3 gives you 0. We have 5 minutes left. We got 1 page to go.